So today we're going to be looking at the GCF of polynomials. Now, what we mean when we say GCF, that's referring to greatest common factor. So to illustrate this idea, let's look at these two terms here. I have 2p and 4p to the third power. So we want to figure out what is the greatest common factor of those. In other words, what is the greatest term in common that these two have? So what I notice here is there are a couple components to each term. There is a number, 2 and 4 in both. And then there's a term like p here and p to the third. So what I recognize is that 2 and 4, what do they have in common? What is the greatest number that 2 and 4 have in common? And hopefully you can recognize, well, 4 is just 2 times 2. So I can see here that 2 and 4 have 1, 2 in common. So we would say that the GCF of this is 2, but then we also have to consider the variables p and p to the third power. So what do p and p to the third power have? Well, if you remember what p to the third power is, that's just 1p times the second p times the third p. And so we can realize here that p and p to the third power just have one single p in common. So that means that the GCF of 2p and 4p to the third power is just 2p. And so we're going to use this idea to factor out polynomials using this idea of a GCF. And so here we have a polynomial, 9x to the third plus 6x, and we need to factor this using the GCF of polynomials. One thing to keep in mind, I'll write a little thought bubble over here. Remember back when you learned how to distribute, you would have something like, I'm just going to make something up, 2 times x plus 4. And you would have to distribute this. And in order to distribute it, you would send a 2 to each one of these terms to be multiplied by both of those terms. So this would become 2 times x plus 2 times 4, which would eventually become 2x plus 8. Now, what we're going to do to factor this is we're essentially going to reverse the process of this. We're going to go backwards. And so I'm going to go over here and I'm going to recognize, well, I have two components here, 9 and 6. And then I also have, x to the third power and x to the first power here. So if I want to do this, my GCF, I need to figure out what it is first. And so what do 9 and 6 have in common? Well, 9 and 6, they both have 3 in common. Let's see, is there a greater number? No, because 9 is 3 times 3 and 6 is 3 times 2. So these both just have a 3 in common. Those are the greatest common factors. So it's going to be a 3. And then over here, the x to the third and x to the first power, what do those have in common? Well, that's just going to be one singular x. So my GCF is going to be 3x between these two terms. So now I can take the idea of reverse distributing and I can use this GCF, and we're going to factor it out. So I'm going to pull the GCF out of this term. Remember, we're reversing the distribution process. So when we pull it out, think about what we did up here. When we put it in, we multiplied it into the parentheses. And so if I'm doing the reverse now, when I pull it out, I am dividing it out of the parentheses, dividing by 3x. So when I put in 9x cubed and I divide out a 3x, what's 9 divided by 3? Well, that's 3. And what's x to the third power divided by x? Well, that's going to be x to the second power, because we know x to the third divided by x, that's equal to x to the 3 minus 1, which is x to the second. And then again over here, if I have 6x, and I divide out a 3x, well, what's 6 divided by 3? Well, 6 divided by 3 is 2. And what is x divided by x? Well, that's just going to leave me with 1. And so I don't really have to write that 1, because 2 times 1 is just the same as 2. So I can write my answer as 3x times 3x squared plus 2. And if you want to check your answer to see if you got the right answer, you can always just turn right around and distribute this 3x back in. And if I did distribute the 3x, I would get 3 times 3, that's 9, x times x squared, that's x to the third, 3 times 2 is 6, x times nothing, x times 1 is just x. So 9x cubed plus 6x, that did get me back to my original answer. So you can always check that. But as for now, we know that this is right because we checked it, so I'm going to circle this as my answer. Let's look at one more example. And here we have a little bit longer of a polynomial. So the process isn't really very different. We just now have to find the GCF of quite a few more variables. And so when I look at these numbers, let's just realize that I have the numbers components of each of my terms. And I also have the variable component of each one of my terms. The number, variable, number, variable, number, variable. And so I need to figure out what the number GCF is going to be. So what's the greatest common factor of 45, negative 35, 35, and 5? Well, I may recognize that all of these are multiples of 5. And it can't be bigger than 5 because this number right here, 5, it can't be larger than that because it has to be a factor of 5. And the only factors of 5 are 1 and 5. So thankfully 5 fits into all of these. So we know that 5 is going to be a GCF. And then the variables, what do x to the 7th, x to the 5th, x to the 4th, and x to the 2nd all have in common as factors? Well, they all have an x to the 2nd in common. So let's write our GCF out in front. Let's remember that we're reverse distributing. So instead of multiplying 5x squared in, we are actually going to be pulling 5x squared out. So that means we're going to be dividing 5x squared from both terms after we pull it out. So what is 45 divided by 5? Well, that's 9. What is x to the 7th divided by x to the 2nd? That's going to leave me with x to the 5th after I pull that out. What happens when I pull out 5x squared from negative 35 x to the 5th? That's going to leave me with negative 7 after I pull out a 5, and x to the 3rd after I pull out an x squared. And then same with negative 35 and positive 35. 7 is going to be the factor that is left behind. And then when I take an x squared out of x to the 4th, that leaves me with x squared. And then when I pull out 5x squared from 5x squared, well, what is 5x squared divided by 5x squared? Well, that's just going to all cancel down to 1. So it's going to be just plus 1. Sometimes students forget to write this here. They think since I'm pulling it out, then I can just not write anything there. But remember, we're dividing it out of the parentheses. So we need to make sure we leave this as a 1. Don't forget that. And so this is my answer. And we could check it. We could redistribute that 5x squared in if you wanted to be absolutely certain. And if you redistribute it in, it should get you back to this polynomial up here. All right, I hope this helps. Thanks for watching.